Join me as I challenge you to master surds in minutes. Many students find surds and roots to be so absurd. This is why today we're going to get to the root of this matter. See what I did there? The root of this matter. Simplifying surds require practice and patience, but with the right approach, you can do this like second nature. Surds is a fundamental concept in mathematics, and understanding them can help to simplify so many complex concepts. So today we're going to start off by looking at what is a surd. A surd is a square root that cannot be simplified any further to give an exact value without rounding. Notice I've put some emphasis on exact because you will get a value, but that value will not be the most accurate that it can be. So surds help us to preserve accuracy. So let's have a look in a numerical context. We are given here the square root of 2. And the answer to that, or rather a rounded answer to that, is 1.4142135562. Oh yes, lots of numbers to say. Now, this is not the actual value of square root of 2 because it is a rounded value. Now, this value could have gone on to infinity. So at some point, I have to stop writing this number down so that I have a representation that can be on paper. Another example here now is square root of 4. You can see here there is a huge difference. The answer is just either positive 2 or negative 2. Now, negative 2 and positive 2 both together multiplied could also produce positive 4. So minus 2 times minus 2 and positive 2 times positive 2. So if I multiply positive 2 and positive 2, the answer is 4. And also negative 2 times negative 2 also gives positive 4. So we can see here the square root of 4 is either positive 2 or negative 2. Now this is an exact value. Now just to increase your literacy here, if we cannot find the exact value of a root, these are called irrational numbers. So irrational numbers, their values tend to go on to infinity. So therefore, the concept of surds help us to preserve accuracy. Now, we're going to look at some other examples of surds. And I want you to pay attention to the patterns here. Can you come up with a definition as to what values will always produce a surd? So my first example is the square root of 10. The second example is the square root of 3 and also the square root of 8. I hope that you have found the pattern because I can see here none of these numbers are square numbers. Therefore, I can make a generalization here. Numbers that are not square numbers, their roots will always be a surd. I hope that you pause the video, write this down. It's very, very important. And also try to ask yourself, what then other numbers, their roots will also be surds? Now, a very, very important point in our lesson. As a student, as a math student, secondary school, there were so many math concepts. I wonder, why am I sitting doing this? Where in my life can I apply this? And you students say it all the time. You say, Miss, you know, one day when I see you on the street, I'm going to ask you to find the Pythagoras theorem of something. But we expose you as educators to all the variety of concepts to empower you to be the best global citizen you can be. So let's have a look at some careers that uses surds and how that impact on our everyday life. So first, surds are used by electrical engineers. So electrical engineers use surds to help them to calculate the accuracy of dimensions, angles, lengths for creating durable and efficient structures. Now, there are sometimes earthquakes and such happens, and we find that lots of buildings tend to go down very quickly. Could it be that these were just estimated measurements that were used to make these buildings rather than the exact value, and that has impacted the quality and durability of structures? Another application is also architecture. So surds are utilized to optimize the geometric designs of buildings, those beautiful malls and so that we go into, and also to obtain the accuracy for those building projects. Can see very, very important math concept here. And the final one I look at is the optical lens and designs. Now, the quality videos that you will get and you watch on YouTube or on any form of social media platforms, these videos are influenced in the background by surds, because what they do is help systems to create very accurate focusing, and they minimize the distortion of the images that we get on our phone. So you see, sometimes when you say, oh, the picture quality is so good, surds are also in the background of that. Now, with that real life application, I'm sure you will much more appreciate this topic. So let's get into the root of this matter. Now, what I find as well is some students lack the prerequisite skills that it takes to access surds, and also the ability to interleave other topics in this topic. So, if you're a student who have done simplifying algebraic expressions, you would be better able to access the topic. However, I will not take it for granted that your algebra skills are A1, so let's do a few examples that will prepare you to unlock the topic. So here we're asked to simplify the following algebraic expression. We're asked to add a plus a plus a plus a. So if we look at it, in our previous video, we talked about when we do not see a visible coefficient, the coefficient is 1. So therefore, I could also say 1a plus 1a plus 1a plus 1a, that will be equal to 4a. Now, quite important here, algebraic expressions, they can only be added or subtracted if the variables are all the same. So because all of these were all a's, we could add them together. Now consider the second example. We have add b, add a, add b. We can only add the a terms together and the b terms together. So I'm just going to collect them here. So I'm going to do a, add b, add b. And the answer is 2a add 2b. Cannot be simplified any further because a and b are unlike terms. Now that you get that idea, let's do example number 3. Pay attention now, because here we've got some negative numbers involved. And in previous videos, I've talked about the ability to use real-life context such as borrowing and paying to simplify the concept of addition and subtraction of negative numbers. So again, like I've done previously in question 2, I'm going to put my like terms together. So I've got 7e. Very important to note here that this is not just 2e but minus 2e. We're going to write 7e minus 2e. And also I've got positive 9g. Notice I wrote my positive first because it's very much easier to manipulate, because clearly when I now write minus 8g, it's very clear that I need to subtract them. So my final answer for that is going to be 7e minus 2e is positive 5e, and positive 9g take away 8g is just g, or if you wanted to write 1g, that's also okay. Now, once we've understood this, surds will be so much easier to appreciate, So let's do a few multiplications since we're also going to explore those. So I am given here, asked to simplify 8 times by y times by 2. All I need to do is to do 8 times by 2, which is 16, and then my variable term is y. So the answer is 16y. I then go ahead, do the same for the second example, even though I've got negative numbers, but we know the rules that apply to multiplication of negative numbers. If there is one negative, the entire answer will be negative in multiplication or division. If I have 2 negatives or any even numbers of negatives, the answer will be positive. All negative numbers in multiplication and division must have a matching pair if our answer is going to be positive. So I just need to do 8 times by 4, which is 32. So this is minus 8. So I'm just going to multiply them and then take care of the negative. So 8 times by 4 is 32. So I'm just going to write that down. And then I'm going to multiply that by 3. Notice here, I did not just think it, I also ink it. So 3 times 2 is 6 and 3 times 3 is 9. However, I have a negative value here, so my answer is going to be minus 96, and then I consider my variables. So a times c is ac, and then multiplied by d will be ACD. So the final answer then is negative 96 ACD. I simply combine my letters together. Now, I've got the final example of our prerequisite task. So I'm asked here to square everything that's in this bracket. So I'm just going to go ahead and write this out. So I've got 4CD times by 3, and then I need to multiply that all by itself. So I've written it out twice. So then all I need to do is to multiply all the numbers together. Now I've specifically put this here just to remind you that when numbers and letters are together, the operation that's happening between them is a multiplication. So I'm just going to put all my numbers together. I'm going to do 4 times 3, that's these two here, and then I'm going to multiply that by 4 times 3, that's these two here. So let's take care of our numerical factors first and then collect the letter terms after. So 4 times 3 is 12, and you can see I've got another 12 here. So 12 times 12 is 144. And then I need to consider c times c is c squared, and d times d is d squared. So my final answer is 144 c squared d squared. Okay, with that foundation being laid, we are now going to go into our surds. Now, the same skills that we have just explored are vital to accessing the concept of surds. So, first of all, we're going to talk about adding and subtracting surds. Now, I would suggest that you write this down. It's very important. Writing does help to solidify your concept that you have explored, or even talking it back to yourself or to someone. So when simplifying surds, you must add or subtract similar to what we have just done in algebra. We can only add the like terms together. Therefore, surds can only be added or subtracted if their roots are the same. Similarly to how we said only A terms could be added together and only B terms could be added together. If the roots are not the same, surds cannot be added or subtracted. So let's go into some practical examples. I'm asked here to simplify 2 root 5 plus 3 root 5. The first observation here is that both of the roots are the same. Yes, that means these are compatible. So all I need to do is to collect the coefficients of the root, which is 2 and 3. So once I've added those together, I will simply keep root 5 as a part of my answer. So 2 add 3 is 5, and my common root is 5. So the answer is 5 root 5. Now, in general, A root C plus B root C will always be equal to A plus B root C. And again, you write that down. Now, the same principle applies for subtraction of numbers. Roots are the same, we subtract coefficients. So here, I'm just going to do 8 subtracting 5 will give me 3, and the common root is 5. So the answer is 3 root 5, and a generalization here is that A root C take away B root C will always be A take away B root C. Common root will be our answer without repeating. Well done. I'm so happy that you've made it this far in the video. It tells me that you are truly interested in improving your Surds. So now that we've done that, we're going to do a few more examples that incorporates BIDMAS, which means that the order of the operation matters when there are multiple operations. So if you look at this example, you'd see that we are asked here to do 2 root 6 add 3 root 6 minus 3 root 6. So now there is more than one operation that we need to do. Now, what does BIDMAS say? This is something that most students are good at. They will tell you BIDMAS. So remember, let's write it down. Very important to visualize as you go along. So BIDMAS. So this means brackets first if there are any. If there are no brackets, we move along. I is for indices. We take care of our powers if there are powers. If there are no powers, we go to the D for division. You can see here we have, I'm just going to X them as I go. There are no brackets here, no indices, no division, no multiplication, which means therefore we need to do addition first before our subtraction. So again, I observe, I ask myself, questioning is very, very important to give you a logical thought as you go through the process. So now I ask myself, are the roots the same? And the answer is yes, they are. So that means I can go ahead. So I just need to do 2 add 3 for the first section here. I get 5 root 6. And then I'm going to put back the part I haven't used yet. So now it's going to be 5 root 6 minus 3 root 6. So now I've done my addition. I'm now going to focus on my subtraction. Again, my roots are compatible, so I can now do 5 minus 3, and that's equal to 2 root 6. And there we go, we've got it. Now, another example. All addition, I check. Are my roots the same? And the answer to that in this question, there are only 2 roots that are the same. One of them is not compatible, just like we had A and B. So now I can only add the 2 that have the same root, and the other one will just be left adding on, but not a final answer. So I go ahead, 3 add 3 is 6, common root is 5. So I've got 6 root 5. I now need to just write back, add 3 root 3, a real life context. I cannot add bananas and apples. So if I'm asked, how many fruits do you have in the basket in terms of apples and bananas? I would have to say, I have 3 apples and 5 bananas. I cannot say I have 8 apple bananas. Doesn't work that way. Okay, now let's look at another example. Here, I'm asked to do 3 root 7 minus 3 root 7 add 5 root 7. Now again, compatibility is the same. Roots are the same. Now I want to pause here just to make a clarification on something that I found in my career as a teacher. Now, lots of students know, according to BIDMAS, we need to do addition first. But a misconception here, they believe that you could just go ahead and do root 3 root 7 plus 5 root 7. If you're going to do that, you have to consider your 3 root 7 as a negative, as there is a minus sign before that. Because if you do not do that, your answer is going to be incorrect. So my suggestion to ensure that we do not mess this up is to always collect the positive terms first, add them together, then deal with the subtraction. So what I'm going to do is to do 3 root 7. I'm going to go over and I'm going to do plus 5 root 7. Now when I get my answer, I'm now going to subtract the 3 root 7. So then this will give me 8 root 7. I now rewrite my minus 3 root 7 and I can now see clearly that I am subtracting. So 8 minus 3 gives me 5 and the common root is root 7. There we go. Okay, our last example here is 4 root 13 minus 3 root 13, and I've specifically put this example here just to remind you that there are times when there will not necessarily be a coefficient before the root, and that's because the answer is 1. So 4 minus root 3 is positive 1. I'm just going to write positive 1 common root 3. However, we do not have to put the 1 before the root. We could just go ahead and do root 13, means the same. And why is this important? Because whenever you get a root to add and there is no visible coefficient, students tend to forget that there is an imaginary 1 I need to also add. So a very good question for you to experience. Okay, now having dealt with addition and subtraction, I know you're ready to multiply, and I can feel that some clarification is coming to you. So let's carry on. Now you've got these examples already, so and your generalization, so just to remind you of that. So now we're going to move on to multiplying and dividing surds. And remember, the generalization is very important, so pay attention to that. Pick up patterns as you go along. So when multiplying surds or dividing, we go back on our algebraic foundation. So we've explored that at the beginning, and now we're going to apply that concept. So we still follow the algebraic rules. So let's consider this example here. We're asked to do root 3 multiplied by root 5. And this one is really simple. All we need to do is to just combine them together as 1. So it's going to be just like we did to A and B, and we got AB. So root 3 times root 5 is equal to root 3 in one root multiplied by root 5. So root 3 times root 5 gets us to root 15. And that's simply our answer. Now in general, root A multiplied by root B will always be root AB. So now, what I've just said to you about an invisible coefficient will apply in the next question. So here, I'm asked to do 3 root 2 times by root 3, sorry. So if you can see here, no visible coefficient before the second root, which means the answer is 1. So if you're the student who tend to forget, as you see this question, you write your 1. So I'm going to do that for you. So just put a 1 there. Straight away, your thoughts come back that this 1 is also a part of the question. So I need to, in this case, I need to multiply my coefficients together. So I need to do 3 times by 1, and also, as the example we did before, I now need to do root 2 times by root 3. You can see here, I have collected the like terms. So the like terms are coefficients, which is 3 and 1. Those go together as a whole number, and those numbers will be before the root. And then I collect the roots together. So 3 times 1 is 3 and 2 times 3 is 6. So my answer then is 3 root 6. Awesome. Now, in general, A root C times B root D will always be equal to AB root CD. Very good. So make sure that you go through the rules, you practice, you access other questions, and you embed that skill that you are learning today. Now we go to division. Amazing. So our progress is, I feel, very smooth. Little chunks, and this is how you learn. Do not try to take on too much at a given time. Do it in very small chunks. And that will help you to balance your time and to minimize any frustration you may feel. So now we're going to do root 20 divided by root 2. And the same principle applies for multiplication. So we just simply need to do root 20. We're going to put them in one root divided by root 2. So root 20 divided by root 2 is equal to root 10. And simply, that's our answer. Now, we're going to be getting in our next lesson to understand that roots could also be further simplified. But for this particular lesson, we're just going to leave them in their root forms unsimplified, because the idea here is to build the concept of the operations involved here and the generalization of the rules. And once that is solidified, we're going to go further into breaking them down in further simplified versions. So again, we go for generalization. So in general, root A divided by root B will always be equal to root A over root B, and we collect them in one root. Now we go to another one, where this time we've got coefficients before our roots. So I know that you're picking up the patterns now because we did that in the multiplication. So if you want to, pause the video, challenge yourself, stretch yourself, let's go. So I've got 10 root 21 and I'm asked to do divide that by 3 root 3. Again, I collect my like terms. So I'm going to do root 10, so I'm going to do 10 divided by 3, and then collect my roots, which is root 21 divided by root 3. So I could just put them roots like that. So if you can see here, 10 divided by 3 will not give an exact value. So under exam conditions and also on a non-calculator paper, it would be better to keep it as it is rather than trying to simplify it. And then just simplify only the roots. I'm going to keep 10 thirds, and 10 thirds here is an exact value. Now, if I divide 10 by 3, what it will do is produce an irrational number. It's going to be a recurring decimal, which at some point will have to be rounded, which takes away from the accuracy of the number. So just keep your value as 10 thirds. And then let's simplify the root. 21 divided by 3 is 7. So the answer then would be 10 thirds root 7. And then we go for our generalization. So in general, C root A divided by D root B will always be CD root A divided by B. And you pause, you write that down, and you practice it. Now, one of the things I find that helps learning permanent, particularly formula, every time you learn a new concept, always write the formula before you answer every question. It's called rote learning. That helps you to keep that permanently in your mind, because some exams do provide the formula, but not all the formulas. So some of them you will have to remember. So practice that, write it down until you really know the formula, then you can stop doing that. So we're going to go into some other examples of dividing surds. But have you subscribed yet? If you haven't subscribed yet, go ahead and subscribe. Hit the notification bell. Send the link to a friend so they can benefit from this beautiful concept of surds. Now I trust you to do that. So let's go into another example. So here I'm asked to simplify root 48 divided by root 4. Now we remember, we just simply need to put them in one square root, root 48 divided by 4. Now it's very, very important that you know your timetable in depth. This gives you an advantage on your non-calculator paper. It helps you to move according to a suitable pace so that you can finish your questions all together. So then, root 48 divided by 4 is equal to root 12. Now, like I said before, root 12 could also be further simplified, but that will be taken care of in part 2 of this series, which means you need to be there. So we keep our answer in that form. We then go on to do 6 root 8 divided by 2 root 2. So again, we learned before we need to combine the like terms. So we're going to do 6 divided by 2 and then root 8 divided by 2. So 6 divided by 2 is 3, and then root 8 divided by 2 here will give us 4. Now you'll notice here, root 4 is not a surd. I hope you noticed that, because square root of 4 have an exact value. So therefore, we need to simplify. So square root of 4, remember we discussed, could either be positive 2 or negative 2, which means that this answer has 2 possible solutions. So it's going to be 3 root 4 could be 2. So 3 times 2 is 6. That's if we use the positive value. And then it could also be 3 times by minus 2 if we use the negative value. So the answer to this question could either be positive 6 or negative 6. Absolutely fantastic. A very, very important thought there. So, you know, sometimes in the exams we'll say, give you one question and they say, find the values of. The clue here is always linked to the fact that a square root has 2 values. So if they ask you for the values of a single question, this is something you need to pay attention to, because here you can see there were 2 answers. Another exam nugget there. Now, going to look at another example. We've got root 12 divided by root 3, and root 12 divided by root 3 is root 4, and we've just explored that that's not a surd. So that can be simplified to positive or negative 2. Great. Now we are going to do the final example. Then you're going to pause the video, you're going to have a go at the questions here, then I'll display the answers. I've also starred 3 questions just to see, has your thinking process been developed? So again, I have multiple operations here because I've got a multiplication and a division. Now, when we have multiplication and division happening in a question, we can take care of them simultaneously. So therefore, I'm going to collect my terms. I'm going to do coefficients first all the way through. I have 3 multiplied by 4 divided by 2. And then in my root, I will have 3 times by 8, and then dividing by 2 for the root. So let's go and take care of the coefficients first. So 3 times 4 is 12. 12 divided by 2 is 6. Then in my root, I've got 3 times 8, which is 24, and 24 divided by 2 is equal to 12. So the answer is 6 root 12, but in our next lesson, we're going to look at further simplifying that answer. So make sure you get that down. See, we manipulated both the multiplication and the division at the same time in this question. But remember, we check our answers. I'm just going to do that. So 3 times 4 is 12. 12 divided by 2 is 6. So we finished with our coefficients. We go back. We now need to do root 3 times root 8, which is root 24, and then divided by 2. 24 divided by 2 is 12. We keep our answer. Now, I have the deepest confidence in you that you have mastered this now. So here's your chance to prove that. So I have created some questions here in a little bit of challenge progression, gold and bronze, silver and gold. And of course, you are a gold star student. So I want you to go all the way up to gold. And then after you've done that, I have put the answers in on the next slide. So I'm just going to display the answer. By now, you should have paused, completed this, and then come back to check on your answers. So I'm just going to have a look only at the star questions because the other ones are basically fluency. I'm just checking to see. I know you would have gotten up to 3 root 36, but did you recognize that root 36 is not a surd? Therefore, for this part, you should have done 3 multiplied by square root of 36 is 6, and that's how we got the answer 18. 3 times 6 is 18, and again, we could also have had 3 times minus 6, which equal to minus 18. So those were the possible 2 solutions there. And the same principle apply for the next question on gold. So root 25 also is not a surd because the square root of 25 is either positive 5 or negative 5. So the answer, if in positive, would be square root 25 is 5. That gave us our positive 45. But also, it could have been a negative. So it could have been negative 45. And then the final one here, you would have gotten 3 root 9. But 9 is a square number. Therefore, root 9 is not a surd. So you could have also done 3 times by square root of 9 is 3. And that's how we got 9 there. And also, it could have been negative 9 if we use the negative square root value of 9. So we're going to now talk about our key takeaways. What are you leaving this lesson with? So just to point you to how to summarize as a student, these are the key points that you needed to have take away from this lesson today. So first of all, we looked at addition of surds. We know in general that A root C plus B root C will always be equal to A plus B root C. This means that I can only add or subtract my surds only if the roots are the same. Then we looked at the subtraction. So A root C minus B root C will always be A minus B root C. And then for a multiplication, root A times root B is equal to root AB. And then for a subtraction, before we get to subtraction, what if we have coefficients? So if we have coefficients, then A root C times B root D will always be AB root CD. And then for our division in general, root A divided by root B will always be equal to root A divided by B. And then if we have coefficients, C root A divided by D root B will always be equal to C divided by D root A divided by B. I hope that I've managed to bring some clarity to this concept and also to help you to recognize that what you do in the classroom is not isolated from what happens in our everyday life. We are living by mathematical concepts every day. And we have to expose you so that you have all the possible choices as you select your careers. So at this point, I'm going to go back to reiterate something. Have you yet subscribed? Have you told your friend to subscribe? Have you told your friend's friend to subscribe? We need to work together to build this community. So subscribe, share, hit the notification bell. Lots of goodies are coming out for you over the next few weeks. And for those going for exams, lots of beautiful exam nuggets will be coming. So thank you so much for being a part of this community. And I hope that you have enjoyed today's lesson. Looking forward to see you in the next few lessons.